Good afternoon, students. Today we are going to discuss about the stability of half-filled subshell and completely filled subshell, and also about the electronic configuration of atoms. Students, आज हम लोग डिस्कस करेंगे कि कैसे हाफ फिल्ड और कम्प्लीटली फिल्ड सबशेल में फिलिंग होती है इलेक्ट्रॉन की, और कैसे हम डिफाइन करते हैं कि कौन ज़्यादा स्टेबल है, विच इज़ मोर स्टेबल, एंड ऑल्सो वी विल डिस्कस अबाउट the electronic configuration of atom. So students, let us begin. Students, अगर हम बात करें stability of completely filled and half filled subshell, so for this we have to just assume two conditions, that from where we can judge that the half filled orbitals and completely filled orbitals are more stable. So students, the very first is the symmetrical distribution of electron. Okay, that is, whenever we are taking the case of half filled orbital or half filled subshell and completely filled subshell, what happens there is symmetrical distribution of electron. How I am saying this, or how you can understood this, let us see. Students, suppose we have s orbital, suppose करिए हमारे पास s subshell है. So we all know with the fact that s subshell have मैक्सिमम 2 इलेक्ट्रॉन. एस सबशेल में, एस ऑर्बिटल में मैक्सिमम कितने इलेक्ट्रॉन्स आ सकते हैं? 2. ओके, सो स्टूडेंट्स, सिमिलरली फॉर पी ऑर्बिटल देयर इज़, फॉर पी सबशेल देयर इज़ 3 ऑर्बिटल्स. पी सबशेल के लिए क्या है? 3 ऑर्बिटल्स हैं, एंड द मैक्सिमम नंबर ऑफ इलेक्ट्रॉन दैट कैन बी फिल्ड इन पी सबशेल इज 6. ओके, एंड स्टूडेंट्स, द सिमिलर ट्रेंड विल बी फॉर डी, F, etc. For D subshell the orbitals are 5, and for F subshell the orbitals are 7. Okay, so students, now when we are going to fill this electron, we will see the following trend. Suppose we have 2p3 configuration and we have 2p5 configuration. Okay, so students, in case of both, what you will see, suppose there is 3p orbitals, okay, and there are 3 electrons. So here you can see that there is symmetrical distribution. Students, यहाँ पे आप देख सकते हैं कि अगर हमने p3 इलेक्ट्रॉन्स को फिल किया है तो यहाँ पे इलेक्ट्रॉन्स क्या हैं? सिमेट्रिकली डिस्ट्रीब्यूटेड हैं. बट इन केस ऑफ p5 यू विल सी दैट, बट आप जब p5 को देखेंगे तो आप देखेंगे कि यहाँ पे सिमेट्रिकल डिस्ट्रीब्यूशन नहीं है. देयर इज़ नो सिमेट्रिकल डिस्ट्रीब्यूशन. दैट्स वाई द हाफ फिल्ड, दैट इज़ p3, इज़ मोर स्टेबल दैन p5. ओके, एंड सिमिलर विल बी द केस फॉर अदर ऑर्बिटल्स ऑल्सो एंड अदर सबसेल्स ऑल्सो. सपोज दैट स्टूडेंट्स, फॉर वी आर कंसिडरिंग द d orbital. Okay, as we are discussing about the d orbital, so here we have taken 2 configuration, 3d6 and 3d10. So students, for 3d6 you can see here there is not the symmetrical distribution of electron. यहाँ पे क्या, इलेक्ट्रॉन सिमेट्रिकली डिस्ट्रीब्यूटेड नहीं है. 4 ऑर्बिटल्स में हम देख रहे हैं सिंगल इलेक्ट्रॉन है, लेकिन एक ऑर्बिटल में क्या है? 2 इलेक्ट्रॉन है. बट स्टूडेंट्स, इन केस ऑफ d10 you can see that in each orbital there is equal number of electron, or basically we can say that there is symmetry. Okay, so students, this is the very first guiding rule which explain about the stability of completely filled and half filled orbital over less filled orbitals. So here we can see that the completely filled or half filled subshell have symmetrical distribution of electron in them and therefore are more stable. Now students, there is one more criterion, that is exchange energy. So students, whenever we are going to dealing with exchange energy, we must have to know what exchange energy is. So students, the stabilizing effect arises whenever 2 or more electron with the same spin are present in the degenerate orbital. Students, आपको पता है degenerate orbitals क्या हैं? Suppose we are considering the p orbital. So this is a degenerate orbital, that is each orbital have the similar energy. And suppose we have filled each orbital with one electron. Suppose हमने हर orbital को 1 electron से fill कर दिया. So again their energies are equal. So students, we are considering the condition where these electron can exchange. Okay, so this is basically called as the exchange energy. इस energy को ही हम क्या कहते हैं? Exchange energy कहते हैं. Now students, these electrons tend to exchange their position and energy released due to this exchange is called exchange energy. You can see here we are taking an example of 3d5, okay, d subcell having 5 electrons. So for this student, you can see if there are half filled configuration, then this very first electron can exchange to 1, 2, 3 and 4 consecutive orbital, okay. Again, if we are considering the second electron, it can exchange to 1, 2 and 3, okay. So you can basically see that 4 exchange by the first electron, 3 exchange by the second electron, 2 exchange by the third electron and 1 exchange by the fourth electron. So students, the stability of half-filled and full-filled orbital is because of symmetrical distribution of electron and also the exchange energy, okay. Now students, suppose the number of exchange that take place is maximum when the subshell is either half filled or completely filled, okay. So whenever the configuration is half filled, the number of exchange will be maximum, or in case of fulfilled also the number of exchange will be maximum, okay. So that's why they are more stable. This is all about today's lecture. Thank you class.